Okay guys, so now we are solving logarithmic equations. Okay, so first we have to condense each log. All right, so these are going to be the steps that you use every single time. So condense the log first. Then from there, use the one-to-one property. All that means if you have the same base, you can just, they're equal. So you can set what is inside your parentheses equal to each other and just solve that equation. So now once you solve it, you have to check for an extraneous solution. Remember when we did that before, it's where you plug your solution into the equation and make sure that they do truly equal. All right, so look at number 1. And since it's log base 5 on both sides, we're going to say 5x plus 9 equals 6x. Okay, and from there, we are going to subtract 5x on both sides. It's just a basic equation. So 9 equals 1x. Okay, and that is a solution when you plug it back in and solve it. So you can just plug 9 into both sides in your calculator. Sorry, not in your calculator. 9 on both sides with your 5 times 9 plus 9, and then 6 times 9. And you know that they equal. Okay, so since they both equal 54, we know that it is actually a solution to the equation. So now the second one, number 2. Again, everything is base 2, so we just set it equal to each other and solve your basic equation. Okay, so from there, we have 1 minus 6n equals 43. 6n, negative 6n, my bad, equals 42. And so n equals negative 7. Again, we're going to plug it in and make sure both sides equal, and they do. Continue. Go ahead and do number 3. Pause your video, and then when you unpause it, you can check your solution. Don't forget to check for extraneous solutions. Okay guys, so your answer to number 3 is actually no solution. Let's look at why, okay? We get 6 equals W when we work it out, but then when we plug it in, we get negative 12 equals negative 12 for your in your parentheses for your log. Logs cannot be negative, so if you plug it in, you get 2 negative numbers that match. Your answer is still going to be no solution, okay? So let's look at number 4. This is the first one where we have to condense the log first. So remember, when we have the same base and we were adding, that really means they're multiplying, okay? So this is the same thing as the log of y plus 5 times 4, okay, equals the log of 72. So we're just going to drop everything now and use the one-to-one property. So now it's condensed, it equals, so I'm going to rewrite it to where it looks a little more familiar. So 4 times y plus 5 equals 72. Okay, so everybody see what we did? We took what we just did last week with the condensing. Remember, if they were adding, that means your big numbers are actually multiplying. And then I just rewrote it to look more familiar because we're going to use the distributive property. So we're going to solve that. 4y plus 20 equals 72. And when you solve that two-step equation, you get y equals 13. We're going to plug it in, and yes, it is a solution. Okay, so now we're going to look at number 5. Again, we're condensing your log first if you can, and here we can because we have a 3 in front. Remember, when a number's in front, that means it's going to become your exponent. So we have log base 7, 4 to the 3rd power, equals log base 7, 4a minus 8. Okay, so the first step was moving your exponent onto the 4. So from there, we have the same base, so we can drop the log base 7 and just make it 4 to the 3rd power equals 4a minus 8. 4 to the 3rd power is 64, So that is equal still to 4a minus 8. So 72 equals 4a, and then a equals 18. And when you plug that in, yes, it does work. All right, so number 6, again, step 1 is condensing each log. So when you look at number 6, first thing we should notice is that minus, okay? When we're condensing the log, that meant that we would divide, okay? Remember when we were adding, it was the logs would multiply. When we were subtracting, the big numbers would divide, okay? So our first step in writing that is going to be log base 4, and then 68 divided by 4 equals log base 4, 3n plus 11. Okay, so now our bases are the same, right? So we just drop them out. 68 divided by 4 is 17. So this is going to become 17 equals 3n plus 11. So then it's just a basic two-step equation. So really condensing the log is the only new part. And don't forget to check for extraneous solutions. So plug it in and make sure it equals. This one does. All right, so now let's look at number 7. So what does that 1/2 in front mean? Good, it means it's the exponent, right? So we're going to rewrite this, log base 6, 25 to the 1/2 power, equals log base 6, 23 minus 4w. Okay? Now, what does it mean when you're raising something to the 1/2 power? It's square root. Okay? So the square root of 25 is what? It's 5. And then we're also just going to bring down 23 minus 4w. Okay, so from there, we're going to solve that two-step equation, okay? And when we do, we will get negative 18 equals negative 4w. And so w is 9. Oh, it's at the very bottom. Hold on, I'm going to move over here. 9 over 2 equals w. So in upper level math, for the most part, we want to keep our answers a simplified improper fraction, okay? So when you divided by negative 4, it became negative 18 over negative 4, okay, which will simplify to positive 9 over 2. That's as much as you can simplify, so that's going to be your answer. All right, so number 8, we're going to notice two things that we have to do, okay? So not only do we have a 2 in front of a log, so that means we have to make it an exponent. We also have two long logs that are subtracting, okay? So that means that that 6 is going to become 6 squared. First, I'm going to rewrite this. Okay, so this is going to be log base 3, 6 squared, minus log base 3 to the 4, And then from there, since it's subtracting, what do we have to do? You have to divide. So log base 3, hold on, I'm not going to write the logs anymore. So then we're just going to write 2p minus 5 on this side. And then over here, we are going to have 6 squared divided by 4, okay? So from there, we bring 2p minus 5 down. 6 squared is 36. 36 divided by 4 is 9, okay? And then we solve the two-step equation, and we get p equals 7. All right, so look at number 9. What do you notice that's different here? There is a quadratic. It's going to be quadratic because it has an m squared. So the first thing we're going to do is write m squared equals 18 minus 7m. Then what was the first thing that we have to do if we have a quadratic? We need to set it equal to 0, right? So we're going to have m squared. So we're going to say m squared plus 7m minus 18 equals 0. Sorry, that's horrible. I'm trying to make it right prettier. So we just moved everything on the right side to the left, okay, by your opposite operations. So then from there, I need two numbers that add together to get positive 7, multiply together to get negative 18. If you think about it for a minute, you realize your numbers are 9 and negative 2. Right? And so then we have m equals negative 9, m equals positive 2. All right, so that is solving the logarithmic equation if you have a quadratic. So your big thing is first you have to get them out of the log if they have the same base. Then you're going to move everything over and equal it to 0. So once you get these two answers, remember we still have to check for extraneous solutions, but both of these will work. Okay? Now, let's look at number 10. So this one's a little different, okay? Why is this one different? Because we have two logs adding together on one side. All right, so if they're adding, that means we're going to multiply them, right? So we're going to have log of 2 times k squared equals log of k squared plus 16. Okay, so from there, we remove our logs because they're the same base. So we have 2k squared equals k squared plus 16. All right, so then we move everything to one side, right? Because it is a quadratic, and we're left with k squared minus 16 equals 0, because that 2k squared, so minus k squared is 1k squared. That's where this one comes from. All right, so then when we do that, it's difference of squares. So when we factor it, it's k plus 4, k minus 4 equals 0. And so when we solve that, we get positive and negative 4. K equals plus and minus 4. And both of those will satisfy the equation when we plug it in. All right, so I am going to stop this video here. And this is log equals log equations, all right? The next video will pick up right here for log equals number equations.